current state, a lot of systems, so we're talking about relational systems, we're talking about traditional legacy type of thing, and you probably have thousands of tables in your relational databases. And if you take a look at your systems and how they're all architected together, you start out with an application, it writes to a database, you're good. Oh, well, there's this new software as a service thing that we want to integrate with. Okay, we'll do that. You might have this back office type of system talking to something on the enterprise side, talking to a line of business. Basically, you get all these point-to-point integrations. If you don't have point-to-point integrations, then you're doing some sort of ETL process from one database to a data warehouse. So there's data flowing around, but it's brittle and it's time-consuming. So that's kind of the current state for the vast majority of enterprises that are out there. So let's talk about what happened over the past. This is like a nice little window, a 5-year slice. Obviously, it's 2023. We're going to get compiled the data for 2022. This came from Gartner, basically an article that was published by Merv Adrian online. And he basically showed the rise of cloud revenue over time. And so what they're looking at is the total database market for all databases, NoSQL, relational, everything. And they show it from 2017 to 2021. And what we see over this 5-year time period is that both of them are growing. The total database market went from about 40 billion, 50 billion to about 90 billion in this 5-year time window. The vast majority of the growth was in the cloud. That's where the vast majority of the database consumption occurred. So that's something to take note of. And then what I want to do is kind of show you the total database market share by year. So I left Oracle in 2017, and I'll kind of walk you through the thought processes behind that. But if you look in 2017, Oracle had 36.1% of the total database market share. Best relational database out there. I worked for the company, I knew it. I knew it was better than Postgres. I laughed at a lot of customers who would take something that was running on a really good Oracle rack or an Exadata and try to move it to Postgres. It just doesn't work, right? Engineered systems count, it works. These are the type of things that were there. So Oracle was strong. And then we look at all the way up until 2021, and Oracle's at 20% of the market share. They lost 16% in that small window, like 5 years. I've kind of done my own little homework, and I think that you're going to see that Oracle now has 16% of the total database market, and that the cloud growth has grown from about 50% to almost 60%. So there's like more cloud than actual on-prem. So this is the trends that we're seeing. Now Oracle hasn't really lost customers, but they didn't get new customers. In other words, they weren't in the cloud because they had their own cloud. So they kind of missed the mark. And I kind of saw that coming, so there's a number of things that happen. Why is this happening? Why is relational having some problems? Why are we moving to NoSQL? And part of it has to do with Moore's Law. And we know like the silicon has a certain limit to where you can actually reach maximum processing, and we're hitting that limit. And so what they're trying to do is come up with more cores, so you can actually distribute that processing in a CPU across the cores. Not everything is distributable. Not everything can really work. So if you look at the processing power, there's another line that's showing how Moore's Law is really coming out. It's not really growing as it should. Sysmore is what they're trying to do with new chipsets to actually improve the performance of a CPU beyond just cores. And that would actually have the true traditional line of Moore's Law. The other thing that's happening is we're having an explosion in database and data in general. And it's not just structured data, it's unstructured data, it's emojis, it's different things, and big data tried to tackle that process up front. There's a lot of different pressure on this. And so this is a really good thing. It's in the article, you can actually watch it. Rick Houlihan was at Amazon, and he was in charge of a project called Rolling Stone at AWS. And you may have remembered where Oracle was kind of poking fun at Amazon, saying that they're one of our best customers. You know, they consume so much of our Oracle software. And Amazon decided, Jeff Bezos wrote a letter to his shareholders saying that we're going to get off Oracle, and we're going to focus on databases. And so Rick Houlihan was the guy who was in charge of that. Instead of going to relational, he went from relational to NoSQL. And they did that because he needed scale. And the thing about the relational database is, and we'll get to this in a second, those joins between the tables, third normal form, is painful. It's computationally expensive. And it doesn't scale. It doesn't scale to the the amount of data that we have in modern infrastructure, modern systems. We're not talking a million rows. We're not talking hundreds of millions of rows. We're talking billions, right? And how does that compute into a relational database? So we'll go back. Oh.
Hello, everybody. Yeah, welcome. Thanks.
That's actually live. I'm going to go to the next slide here. So we basically have Dr. Evil here. It's like, oh, you've got relational data. How about 100 billion rows? How do you solve for that, right? Not an easy task. If you do write a query joining several tables across 100 billion rows, that query is never coming back. It just will not come back. So what do we do? And we've done this for years. We've done this for decades. Basically, we take data from our operational databases on the left, and we move them into a data warehouse through an extract, transform, and load type of process where we take data from one database, transform it, and then load it into a data warehouse. And what we're doing is we're actually putting that into a star schema. Star schema has one or two dimensions, like a time dimension, or something like a region dimension for sales, or something like that. You've joined to a giant fact table. So you've taken 10 joins and put it down to one or two. And then the data actually works. You can actually partition your data by time as well, right? So you can actually break this out, put it into different systems. But that's expensive. And then reporting off of that is also expensive. So what you have is data that's being moved around. And because these operational data stores are used during the day, you typically do this at night. So you get a slow night batch process. And this is what we've done for, I don't know, the past 20 or 30 years. In comes MongoDB. And so basically, when you have like a customer object, and you break that down into customer detail, a summary, an ARR address, all that kind of stuff, you actually, and then you have contact roles that are associated with an opportunity. These are the joins that you have to do behind the scenes. This doesn't work at scale. And if you're looking at customer orders in your Amazon, you're talking hundreds of billions of rows. It doesn't work, right? So you've got to do something differently. They went with NoSQL. If you take a look, this is kind of a simple example of you have a customer, he's got an address, he's got a phone number. This is a join between these tables just to put together the basic contact information for a customer. Imagine joining to an orders table, and an order joins to a product table, a product joins to product features, those type of things. Now you have 10 different things going on in a query. Just to get a report by sales by region, you have to do this in a data warehouse. You can't do it in real time. So Mongo did things differently. Basically, they took the object and stored it as it is. So you go from like a customer object straight into a customer object opportunity. As things come in, you store them together. So anything that's related to a customer, like his name, address, phone number, you put it right in. It goes straight into the database. And there isn't like breaking it down into tables. You don't have to do that. And when you query the data, you don't have to join it. You just pull it back out. You simply look for that customer, and all the data related to him comes back in the document the way you want it to. So that is superior to MongoDB. I mean, MongoDB is superior to Relational. So you basically come back with this. So you have a customer information and everything related to that customer in one document. Every field in this document can be indexed. So it comes back immediately. I'm looking for a particular thing. I'm looking for everyone that lives in New York State. You index the state. Then you get all the documents back that are associated with it instantly. No joins, no computational expensive, nothing. It's just super fast. When I was at Oracle, we went head-to-head with Mongo at a number of places. And we had an Exadata, $5 million machine at a particular corporation. And Mongo came in with 3 servers, like Dell servers, good servers, but not major servers. There weren't $5 million machines. And on the first pass through the POC, we got some of the requirements, we ran everything on our end, and we had our numbers, and we heard what Mongo's number was. We lost, big time. So on the Oracle side, we went back and we pinned data into flash cache on the Exadata so that it was like in memory. It was as fast as it could possibly be, and barely squeaked by. And I was like, oh my gosh, we're dead, right? Because if that's the way, they didn't do any tuning. We did. And if we didn't really knuckle down, we would have lost. And so it was a no-brainer that Mongo was significantly different. It was kind of scary at Oracle because I knew that the game was over. At that point, I was actually in the front line. And I knew it was just a matter of time before everyone else figured it out. And so I do think that's part of the reason that Oracle has declined. It hasn't been selected for a lot of these new cloud projects. I think it's part of the reason that AWS rolled off of them. with the Rolling Stone. And you can watch Moore's Law and all the different things. And he actually does all the charts and graphs on the computation as to why that change is taking place. That's why I really think that things are moving from relational to NoSQL. The ones that do this will survive. The ones that don't will be slow. Batch processes, those type of things will cause companies to fail.